हाय बच्चों, आज हम पढ़ेंगे एक्सपोनेंट। ओके, उसे हम और इंडाइसेस भी कहते हैं, पावर एंड रूट्स भी कहते हैं। तो आज के चैप्टर में हम इसके बारे में डिटेल्स में पढ़ाई करेंगे। ओके, विल गोइंग टू स्टार्ट द एक्सपोनेंट, पावर एंड रूट्स, दैट आल्सो कॉल्ड द इंडाइसेस। Okay, so what is indices, what is exponent, or where we use the exponent, where we use the power. Okay, so if I say to write 2 5 times, okay, so what we'll do here, 2 into 2 into 2 into 2 into 2. So this will be what? 2 5 times. Okay, 1 2 3 4 5 times. So 2 5 times. Okay, so we can write down the 5 times. If I say write down 5 10 times. Okay, so what we'll do here, 1 2 3 4 5 6 7 8 9 10. Okay, 1 2 3 4 5 6 7 8 9 10 times. So this is 5 10 times. Okay, now if I say multiply 2 5 times with 2 7 times, so again what you will do here, again you will be multiplying 2 7 times. So right here, then you will add everything, you will get the answer. But if I'll say multiply, so 2 into 2 4, 4 into 2 8, 8 into 2 16 into 32, then again we have the 7 more times here, then we'll multiply. That become a longer process. So instead of that, we'll come to know the formula or the exponent or the power or the indices. Okay, we'll use that to get the answer. Okay, so suppose we have something 2 raised to 5. How to read this? 2 raised to 5 or 2 to the power 5. 2 is the base. Okay, this 2 is known as the base. This 2 is known as the base and this is known as the power or exponent. Okay, this 2 is known as the base and 5 is known as the power or the exponent. So instead of writing the whole multiplication, we'll simply write 2 how many times? 2 how many times? Though kitni bar? Like here 2 5 times. Okay, so instead of writing 2 into 2 into 2 into 2 into 2, we'll simply write 2 raised to 5. Okay, 2 raised to 5. This is 1 2 3 4 5 6 7 8 9 10. So this we can write down 5 raised to 10. Clear? So big part, big multiplication, okay, we can write down in the short form में. Now what will happen once we write in the small part में, short form में, in the exponent power form में, then we can multiply in this, we can add also in this, we can subtract also in this. So okay, we can do different multiplication, different calculation we can do in this. Okay, so once we get this formula, okay, so the first thing, this we read at 2 raised to 5 or 2 to the power 5, where 2 is the base and 5 is the power or the exponent. Okay, so this is always on the top of this, like a raised to m, a raised to m, a to the power m. Okay, so now here we have few formulas. Okay, so the formula, once you know the formula, you can easily solve the sum. And in indices chapter में this formula is very important, and once if you know the properly the exponent, then you can easily solve the log also, because the log is nothing but they are just reciprocal, you can say, or they are correlated to each other, exponent and log. So suppose we have the first formula, a raised to m multiply by a raised to n. Okay, then a raised to m divided by a raised to n. Okay, so multiplication का one rule we have, then division का one rule we have, then we have a raised to m raised to n, then we have a raised to 0 का one formula. Okay, then we have a raised to minus m का one formula, then we have a into b raised to 1 का formula, a into b whole thing raised to m का formula we have, then we have a upon b raised to m का formula we have. Okay, then in this only, so actually this is the 1 2 3 4 5 6 7 is the main formula. In this only, okay, we have to know what is the meaning of root a, what is the meaning of cube root of a, okay, what is the meaning of 1 upon square root of a, 1 upon cube root of a, okay, then 1 upon nth root of a, okay, then nth root of a also without denominator, a also, then you can write down here one more, that is nth root of a raised to m. This actually come in the surd part में. Okay, this is actually formula for the surd, SURDL, surds. Okay, so here the main formula is the other formulas, and if you know this formula, this is important for the exponent chapter itself as well as the log also. Okay, so the first formula we have a raised to m into a raised to m. So the important part, if you see properly here, both the bases are same, both the base is same. So whenever the base is same, whenever base is same, this is also a, this also a, so and it given multiplication, so it become a raised to m plus n. Okay, what is the rule? Whenever both the base are same and is given multiplication, so we'll add the power. Okay, whenever it is both the base are same and is given multiplication, so we have to add the power. Same way, whenever both the base are same and division given, so we'll subtract the power. Clear? A raised to m plus n, then if it is division given, so a raised to m minus n. Same way, if it is given a raised to m raised to n, okay, means power given, power ka power they had given, so we'll multiply both the power, we'll multiply both the power. A raised to m raised to n given, so it become a raised to m multiplied by n. Then anything raised to 0 is 1, anything raised to 0 is 1, but the very important part, a is not equal to 0, a is not equal to 0, a raised to 0 is 1, but when it is, when a will be any positive number or any negative number, but a cannot be 0, a cannot be 0, so a is any positive number or negative number, so anything raised to 0 is 1. Sometimes they ask true or false, so it is false. Okay, a raised to 0 is 1, it is not always 1, it is only for positive number and negative number. So if they ask you a raised to 0 is equal to 1 always, no, it is not always. A is not equal to 0, then only it will be 1 unless it is not defined. Okay, then anything raised to negative number, it will be 1 upon a raised to positive number, that is 1 upon a raised to. Okay, so a raised to minus m is equal to 1 upon a raised to m. So means whatever raised to negative number given, so if you do reciprocal, it will become 1 upon a raised to m. Okay, the next one is when the base is not same but the power is only 1 given. So we can separate this a raised to m then multiply by b raised to m. Okay, here one more very important thing, this is given multiplication. Okay, a plus b raised to m is not equal to a raised to m plus b raised to m. Okay, this is not equal to, understood, this is not equal to, because we use the formula na, a plus b whole square is not a square plus b square, it is a square plus 2ab plus b square. So this rule is applicable for multiplication and division, not for addition and subtraction. Okay, so a into b raised to m is a raised to m into b raised to m, and a upon b raised to m is equal to a raised to m upon b raised to m. Clear? So these are the main 7 formula which you have to by heart to get the answer, and afterward once you get the log chapter, so log is also based on the indices rule only. Okay, so whatever rule we have here, these are the very important rule for the school syllabus as well as for the future. If you want to study the log, we will use again this. Okay, and the next part is the what is the value. Okay, if they ask you write root a in the power form. Okay, so root is nothing but a raised to half. Okay, square root or under root of anything is nothing but a raised to half. Same way cube root of a is equal to a raised to 1 upon 3, and if it is given in the denominator square root, so actually it become 1 upon a raised to half. Okay, then by using this formula, if we write in the numerator, so become a raised to minus half. Okay, so whatever given root of a, that become a raised to half, but if it is given in the denominator, so that become a raised to minus half. Same way 1 upon cube root of a is nothing but a raised to minus 1 upon 3. Then same way 1 upon nth root of a is nothing but a raised to minus 1 upon n. Okay, and nth root of a is nothing but a raised to 1 upon n, and this will be actually a raised to m and then raised to 1 upon n, so it become total combined become a raised to m upon n. Okay, so a raised to m into a raised to n is a raised to m plus n. A raised to m divided by a raised to n is equal to a raised to m minus n. A raised to m raised to n is equal to a raised to m into n. A raised to 0 is equal to 1, where a is not equal to 0. A raised to minus m is equal to 1 upon a raised to m. Then a into b raised to m is equal to a raised to m into b raised to m. Then a upon b raised to m is equal to a raised to m upon b raised to m. And then square root of a is equal to a raised to half. Cube root of a is equal to a raised to 1 upon 3. 1 upon square root of a is equal to a raised to minus half. 1 upon cube root of a is equal to a raised to minus 1 upon 3. Then 1 upon nth root of a is equal to a raised to minus 1 upon n, and if it is only nth root of a given, so a raised to 1 upon n, and nth root of a raised to m is nothing but a raised to m upon n. Okay, so now what we'll do here, we'll take the 1 part. Okay, before that the one small sum they can ask you like this type of sum, write down 2 5 times in the exponent form. So 2 5 times will be 2 into 2 into 2 into 2 into 2, and then 5 times in the exponent form will be 2 raised to 5. So this type of sum also they can ask in the paper. Okay, like write down 5 10 times in the exponent form, so 5 raised to 10. So whatever number they given and they ask anything raised to that or that many times, so we write here that raised to whatever times they ask you. Okay, so that can be a normal number, that can be a fraction also. Like we have 1 upon 2 into minus 1 upon 2 into minus 1 upon 2 into minus 1 upon 2. So that you can simply write down minus 1 upon 2 whole thing raised to 3. Okay, instead of multiplying that, and then minus 1 ka cube is equal to minus 1 and 2 ka cube is equal to 8. So instead of doing all this, we can simplify directly after writing in the exponent form also. Okay, so now we'll do 1 formula ka, we'll do few sums. Okay, so let's do the examples. Like the first one is evaluate 3 upon 7 raised to 3. So okay, this type ka sum they can ask. So what we have to do here, 3 upon 7 raised to 3 given, meaning it will be 3 times into 3 upon 7 into 3 upon 7, and then we have to multiply 3 into 3 9 into 3 27, and then 7 into 7 49, 3 ja 343, 340 proper it is na, 49 into 7 63, 6 9 28 34, yes, it will be right. So 343. Actually we can find out the 3 ka cube and 7 ka cube also. So the answer is 27 upon 343. Okay, same way the second one, minus 5 upon 6 raised to 4. So see, one thing you can just write down minus 5 upon 4 minus 5 upon 6 into minus 5 upon 6 into minus 5 upon 6 into minus 5 upon 6. Okay, then you will multiply minus 5 into minus 5, the answer into minus 5, then again that answer into minus 5. But instead of doing that, what you can do here, any, okay, actually in the formula also you can write down the one more formula here, minus 1 raised to, okay, first 1 raised to any number is equal to 1. Okay, 1 raised to any number is equal to 1, and minus 1 raised to odd number is equal to minus 1, and minus 1 raised to even number is equal to plus 1. Okay, so actually this is not the formula, this is the basic concept it is. So 1 raised to any number given, it will be 1, and minus 1 raised to any odd number given, then the answer will be minus 1, and minus 1 raised to any even number given, then it will be plus 1. Okay, so we'll apply the same rule here also. Now we'll take only minus, or you can say minus 1 raised to 4. So minus raised to 4 minus raised to even number, the answer is plus. Okay, minus, so no need to multiply minus into minus into minus into minus. Okay, directly you can say, or you can see also minus into minus become plus, plus into minus is minus, and minus into minus become the plus. So the answer is plus, but instead of doing that, you just count how many times it is given. So minus given raised to 4 means 4 times given, which is even number, so the answer will be plus. If it is odd number, the answer will be minus. Clear? And then next will be 5 into 5 25, 25 into 5 125, into 5 is 625, or you can say 5 into 5 25, 5 into 5 25, so 25 into 25, that gives you 625. So this will be 5 raised to 4 is 625. Next one is 6 into 6 into 6 into 6, that will be 6 raised to 4. You can say 6 into 6 36, 6 into 6 36, then 36 into 36 1296, or you can multiply also and you get the answer. So the answer is 125 over 1296. Okay, so that different ways are there. You can multiply 6 into 6, 36, 36 into 6, that will give you 216, 216 into 6, that give you 1296, or you can multiply 36 into 36, that is nothing but 36 का square, and this square का rule already we did in the previous lecture में. Okay, 6 का square, so we have to do in the 3 parts में, 1, 2 and 3. So the first part is 6 का square 36, then multiply both the number and double it. So 3 6 ja 18, 18 2 ja 36, and then 3 ka square 9. So write the ones place number here, then 3 comes here, 36 plus 3 become 39, so 9 here, 3 comes here, 9 plus 3 12, so 1296. Okay, so you can do by that way also, you'll get the answer. Next one is minus 3 upon 4 raised to 5. Okay, so now again negative number raised to 5 given. Okay, minus 3 upon 4 into 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 minus 3 upon 4. Okay, so just count how many times given, raised to 5, which is odd number, or 1 2 3 4 5, which is odd number. So the answer will be minus. Answer is minus. 3 3 ja 9, 9 3 ja 27, 27 3 ja 81, 81 3 ja 243. So the numerator is 243. Okay, then next one is 4 into 4 16, 16 4 ja 64, 64 4 ja 256, 256 into 4 1056. Okay, you can multiply also 16 16 and then multiply 4, 16 ka square 256, 256 into 4, 6 4 ja 24, carry 2, 20 plus 2 20. Okay, then 5 2 ja 4 2 ja 8 plus 2 10, 1024, 1024. So 4 into 4 16, 16 into 4 64 into 4, 64 into 4, that give you 256, 256 into 4, that give you 1024. So minus 243 into minus 243 upon 1024. So this will be the answer of the third one. Okay, let's do few more sums. Okay, so next part is expressed in exponential form. Yes, like last we did, the last part we did, they had given the exponential form and they asked the simplify, evaluate. Okay, here they given the simplified form and we want the exponential form. Exponential form meaning something raised to, like a upon b raised to m form में. Okay, so what we have to do here, we have to think a number. Okay, something raised to like any number raised to give you 256 and something raised to the same number give you 625. Okay, so what we can do here, now this is ending with 5 given, so I can directly say this will be what, 5 raised to 4. Okay, 625 is nothing but 5 raised to 4. So 256 also we have to write something raised to 4 only. So you can do here 256, you can divide by 4, 4, 6 ja 24, 1, 4 4 ja, then again 4, 16 ja 4, 4 ja 4, 1 ja. So that become here 4 raised to 4. Now here the question come, so why you took the only 4 raised to 4? You can cancel by 2 also, you can get the answer 256. Okay, it goes in 2 also, 1 ja, 2 ja, 8 ja, then again 2 ja, this 64, again 2 ja 32, again 2 ja 16, 2 ja 8, 2 ja 4, 2 ja 2, 2 ja 1. So this will be 1 2 3 4 5 6 7 8. So this we can also write down 2 raised to 8. Okay, now what I told here, express in exponential form. So you have to write down in the form of a upon b raised to m. So if you see properly, a upon b raised to m is nothing but this m will be common for the numerator as well as for denominator. So that's why, see, the 2 raised to 8 also give you 256, but we want the power 4. So power 4 meaning the base has to be the 4. So the answer is 4 upon 5 whole thing raised to 4. Okay, so the answer is 4 upon 5 raised to 4, not 2 raised to 8 upon 5 raised to 4. Okay, so that will be the two separate part come, but actual answer will be 4 upon 5 raised to 4. Okay, same way minus 1 upon 512. So first 512 ka we have to find the factor. 512 will be what? 512. Okay, actually if you see this same sum here, if at here 512 and then again cancel by 2, so you will get the factor of this directly. Okay, which is 1 2 3 4 5 6 7 8 9. So this is nothing but 2 raised to 9. Now the numerator, that you can again write down minus 1 raised to 9, because what is minus 1 raised to 9? That give you minus 1. So the answer for this will be minus 1 upon 2 whole thing raised to 9. Okay, minus 1 upon 2 whole thing raised to 9. Next one is minus 32 and then 3125. Okay, again ending with 5, so that will be something raised to 5 only. Okay, so 625 we have raised to 4. If you multiply 625 into 5, okay, into 5, so 5 has a 25, carry 2, 5 has a 10 to 12, carry 2, 6, 30, 31. So 3125. So yes, that will be 5 raised to 5, 5 raised to 5, 5 raised to 5, and this 32 is 2 raised to 5. So minus 2 upon 5 whole thing raised to 5. Okay, whole thing raised to 5, not 3. It is 5. So if you see properly, like if your multiplication, you're squaring the number, okay, if it is good, then you can easily solve these sums unless you take some times. Like I know 625 is 5 raised to 4 and I just multiply with the 5, so I got 3125. That means this is 5 raised to 5. Then this was like we did 256 raised to 4 give you 4 raised to 4 give you 256, or 2 raised to 8 give you 256, and we had 512 which is just double of this. So if this is 8, so that will be 9. So minus 1 upon 2 raised to 9. So 2 raised to 9 give you 512. So again this will be totally depend on the calculation. If your calculation is good, you can easily solve, unless it will take some time, but if you do practice, you can easily solve the sum. Okay, let's do the next part. Okay, let's do few more sums based on the formula whatever we did. Okay, so when the base are same and its multiplication given, so we have to add the power. So that become here, both base is given 4, so 4 raised to 3 plus 5, that become 8. So 4 raised to 8. The next one is, now this is division given, again both the base are same, and so we have to subtract the power. So 7 raised to 6 minus 3, that give you 3. Okay, third one is 11 raised to 3 upon 11 raised to 7, so that give you 11 raised to 3 minus 7, that give you 11 raised to minus 4. So either you write the answer 11 raised to minus 4, or sometimes they ask the write the answer in the positive exponent, so then the answer will be 1 upon 11 raised to 4. Okay, 1 over 11 raised to 4. Then next one is minus 5 raised to 4 raised to 2. So whenever 2 raised to given, you have to multiply. So minus 5 raised to 4 to the 8. Okay, now this is given 5 into 4 raised to 2, so that become 5 raised to 2 into 4 raised to 2. Okay, so write in the simplified form. So you can go further of this. So 5 ka square 25 and 4 ka square, that give you 16. 25 into 16, that give you 400. Okay, and if you do here also 5 into 4 20, 20 ka square give you 400. You can do that also. And then next one is anything raised to 0 that give you 1. Okay, this is non-zero number, so anything raised to 0 give you 1. Okay, now this 4 raised to 8, no need to further simplify. 7 raised to 3, if you want you can simplify further. Okay, because asking to solve here, so you can get the answer 7 raised to 3, you can write down answer 343. Okay, then you can simplify this also further. This is like minus 5 raised to 8 as a big number comes, so you can leave as it is, another to same only it is. Okay, so these are the way to solve. Okay, if you see here, we have to just know the formula in this, and once you know the formula you can easily solve, and they ask for 1 marks 2 marks sum based on this. Okay, so only formula if you know you can easily solve this. Okay, let's do a few more challenging sum. Okay, so like the first one is 4 raised to 2 minus n multiplied by 2 raised to n plus 1 whole thing upon square root of 2 raised to n. Okay, so now if you see the sum, it looks very difficult, but if you go to solve this, it becomes very simple. You have to just follow some basic rule. Okay, first of all, make all the base 2. First make all the base 2. So this will be 2 raised to 2 whole thing raised to 2 minus n multiplied by 2 raised to n plus 1 whole thing upon 2 raised to n raised to half. Okay, step by step, because the square root is nothing but raised to half. So this become 2 raised to 2 2 is 4 minus 2n multiplied by 2 raised to n plus 1 whole thing upon 2 raised to n upon 2. Okay, then again it become 2 raised to 4 minus 2n plus n plus 1, directly here only minus n upon 2, because the multiplication you have to add the power and division you have to subtract the power. So directly in one step may be solved here. Then 2 raised to now 1 minus 2 minus 1 minus 1 minus half, so become minus 3 upon 2n and 4 plus 1 that give you 5. So the answer is 2 raised to minus 3 upon 2n plus 5 is the answer. Proper. 4 plus 1 5, and then this will be minus 2 plus 1 give you minus 1 minus 1 minus half minus 3 upon 2n. So 2 raised to minus 3 upon 2n plus 5 is the answer. Okay, let's do one more sum. Okay, the next one is 81 raised to x plus 1 plus 3 into 9 raised to 2x upon 3 raised to x minus 2 into 27 raised to x plus 1. Okay, now if you see again in this, the base we can take all the base as 3. Okay, take all the base as 3. So now 81 is nothing but 3 raised to 4 and raised to x plus 1, then plus 3 keep as it is, and this will be 3 raised to 2 raised to 2x whole thing upon, this is 3 raised to x minus 2 as it is into 3 raised to 3 and x plus 1 as it is. So that become 3 raised to 4x plus 4 plus 3 into 3 raised to 4x. Okay, upon both the base are same, so 3 raised to x minus 2 plus 3x plus 3 1 3, step by step. Okay, next part will be 3 raised to 4x plus 4 plus 3 raised to 4x plus 1, because this will be raised to 1 given. Okay, now upon 3 raised to x plus 3x become 4x, and this will be 3 minus 1 that give you 3 minus 2 that give you plus 1. Okay, now we can't cancel this and this because there is a plus sign given in between. So what we'll do here further in this, what is common in both? So this is nothing but 3 raised to 4 x into 3 raised to 4 plus 3 raised to 4x into 3 raised to 1 upon 3 raised to 4x into 3 raised to 1. 4x it is, this is 4x. Okay, now what is common in the numerator? So we can take 3 raised to 4x common, and then we have 3 raised to 4 and into 3 raised to 1, so that become 3 raised to 1 is common, so remaining is 3 raised to 3, and this become only 1 because everything is outside, upon 3 raised to 4x into 3 raised to 1. Okay, this is x. So 3 raised to 4x get cancelled and 3 raised to 1 also get cancelled. So 3 raised to 3, that give you 27 plus 1, that give you 27 plus 1, 28. So the final answer is 28 is the answer. Okay, so here it looks like difficult, but if you go step by step now, it will be very simple. Okay, so this is the way we have to solve the exponent, and the exponent we can use in the the real life word problem also. Okay, so suppose if something is given, then any number is given, like the 2 raised to 9 is the number, or suppose suppose they given 45 kilometer, convert into millimeter. Okay, convert into millimeter and write the answer in the exponential form. So first of all, kilometer to millimeter, kilometer to millimeter. So we have King Henry died, mother didn't cry much. So 1 2 3 4 5 6, so directly 45 into 10 raised to 6, that will be 4.5 into 10 raised to 7 millimeter is the answer. Okay, so the other sum you can do in word problem also, in the real life situation also. Okay, so that will do later part mein. As of now we will stop here. Okay, so the main thing here, you can just by heart all the formulas, so you can easily solve the sum. It's a simple chapter, but only based on the formula. If you don't know the formula, you cannot solve the sum.